Assalamualaikum, brothers and sisters. Yeah, are you in?
Yes.
Okay. Now, not many people in at this hour. Shall we start? It's better to start. Okay, one more time. Assalamualaikum warahmatullahi wabarakatuh. Let's start our day with the recitation of Ummul Kitab Al-Fatihah. A'udzubillahi minasyaitonir rajim. Bismillahirrahmanirrahim. Alhamdulillahil alamin arrahmanir rahim maliki yaumiddin. Iyyaka na'budu wa iyyaka nasta'in. Ihdinas siratal mustaqim. Siratal ladzina an'amta 'alaihim ghairil maghdubi 'alaihim waladdallin. Amin. I think our imam not in. I need Brother Amirul. Are you there, Brother Amirul? As usual, we want to start our dua. Brother Amirul, can you help? Are you in, Brother Amirul? Brother Amirul, are you in?
Yes.
Okay. Can you lead the dua because the assigned person is not in? Ya, tafadhal. Ustaz Amirul.
Bismillahirrahmanirrahim. Allahumma nawwir bil kitabi absarana wa shrah bihi sudurana wa sahih bihi abdanana. Fatliq bihi alsinatina wa qawwi bihi jinanina wa asri' bihi fahmina wa qawwi bihi azaimana bihawlika wa quwwatika fa innahu la hawla wa la quwwata illa bika ya arhamar rahimin. Allahumma stawda'na kama 'allamtana fardudhu ilaina inda hajatina ilaik. ولا تنسناه يا رب العالمين. آمين يا رب العالمين.
Amin ya rabbal alamin. Thank you so much, Brother Amirul. Okay, today we are having a new topic, simulation. Simulations. Okay. Now we are looking at simulate. We have to simulate certain thing. So basically, simulation is an experiment on a model of a real system. We develop a model that depict the real situations. Normally mathematical model, or sometimes it is a thermal model. I think you know, like aeroplane or this thing, and they do this wind tunnel just to test whether the model function or not. The same thing, this simulation is used when it is very complicated to develop quantitative approach to decision making. Still quantitative, but we cannot make decisions. So the best thing is to experiment. So it is useful when developing mathematical model is not possible, not literally not possible. That means it's very complex to develop. So we develop these simulations. It is applied to solve problem that has one or more uncertain factors. For example, sales, demand, we do not know, like arrivals in, say, at railway stations, arrival at the bank, or service time in at the counters, at bank counters, traffic movement, and many more. We can simulate this. Maybe our COVID projection also, the health ministry do some simulations, and they do what if situations. That's why they can anticipate by June, maybe our COVID case can reach to about 10,000. it is a method for learning about real system by experimenting with model of the system. So we develop a model that represent the system. Then simulation model contains mathematical equations or expressions and the logical relationship. Just now I said not mathematical, but actually we are using mathematical equations, but simplified. So to make logical relationship that describes the value of the outputs given the value of the inputs. So the input have two things, controllable and some not controllable, probabilistic. Right, arrival, uncertain inputs. So probabilistic inputs. In simulation, the analyst will select a value of the controllable input. You refer this as parameters. And then the value of the probabilistic input referred as uncontrollable input. We use randomly generated numbers, random number. Then the simulation model use the values of the controllable inputs and also the values of the probabilistic inputs to calculate the expected output. So we want to anticipate what will be the outcome after taking into account the parameters, controllable input, and also the probabilistic input or randomly generated input. In simulation model, we can graphically represent a model. So in this case, equations, we have certain parameter or controllable inputs to be put in, and there are something that we cannot control, uncontrollable inputs or probabilistic inputs. And then the model is a set of equations that will generate something, and it will generate some output. Example, let's just go example. New product development. Say you are developing a new product. You want to know whether this product, is there a probability that the product will be profitable in the market? Another one is airline overbooking, to determine the number of reservation an airline should accept. For example, if an airline can take 500 passengers, some passengers, if they book exactly 500, maybe on the last minute, on the last hour, maybe about 4 or 5 people may not turn up. So rather, when these people do not turn up, the seat is wasted. So they can develop a model how much overbook. They purposely do overbooking. When we do overbooking, that means if there are 500 seats, maybe they can use probabilistic input. They book instead of 500, they may allow 505, anticipating maybe 5 people may not turn up on the last minute. Inventory policy, I mean how much you should stock. So to determine an inventory policy so that you can service the customers at a fair amount of cost. Then traffic study, like traffic flow. We can also use simulations at junctions or highway or certain roundabout or intersections. Sometimes you notice some people make some survey, and then how do they analyze this? They want to simulate the traffic. After simulating this, and then they can design the traffic junctions. Waiting lines. For example, you are waiting at counters bank counters, maybe airline counters. So to determine the waiting time for customers, in order to determine how many counters to open. ATM machine, for example, you can determine ATM machines, how long people wait. 3 minutes, 5 minutes, 10 minutes. So it depends on the policy. If maybe the bank, let's say you're in a bank, while waiting for the ATM machine, they want to make a certain servicing time. Maybe they want to allow only maximum 5 minutes waiting. Then how many ATM machine to install? 1, 2, or 3. So these are examples. Okay. So in simulations, simulation is not an optimization technique. So you cannot develop optimization, but it is a method of how to predict how a system function. For example, just now I give example, say ATM machine in a bank or at UIA, how many ATM should be installed? 1, 2, or 3, or maybe like counters, bank counters, how many counters to open, so that it will reduce waiting time, for example. So in this situation, it is predicting how a system operates given certain choices for the controllable inputs and also randomly generated values for the probabilistic inputs. This simulation, it is effective in designing a system to provide a fair efficiency or very good performance when servicing customers. The advantage of simulations, we can develop a real-world decision-making problems, which is exposed to a lot of uncertainties. So we can develop mathematical things, and then use probabilistic uncertainties, and then to develop something. It is time compression rather than we have to wait for maybe the whole year. We can develop this in maybe to reduce this less than a few minutes to develop time to estimate how system functions. The disadvantage, there is no guarantee that the solution is optimal. So it is not an optimization method, but just a study how a system will operate or a system function. And then it require a lot of calculations, a lot of numerical computations in order to make rational decisions. Types of simulations, we have typically we are doing what we call it Monte Carlo simulations. There is a mathematician, John Newman. He adopted the concept of gambling procedures in Monte Carlo, in commercial environment, in business environment, into non-gambling situations. You know, Monte Carlo is known for gambling, casinos over there. They adopt the method of generating this random number and using this in non-gambling situations. So basically generating of random numbers. So we refer this as probabilistic simulation. Other method, we call it system simulation. This is just as testing or commissioning a situations by running a system, for example, air conditioned system or computer system, applied to large system, for example, in a hospital, in a bank, in a government, or just to simulate certain economic situations. This is the roulette wheel to generate random numbers. Okay, let's look into risk analysis. We can use simulation to study risk analysis. It is a process to predict what will be the outcome in the face of many unpredictable things, many uncertainties. So how will things perform in facing these uncertainties? So to develop this, we have to develop certain parameters, or we call it controllable inputs. We will look at it later. Develop certain parameters or assign certain parameters for controllable inputs. And also we also assign situation, what if analysis, risk analysis, what if things goes bad, what is goes good. So it involves generating values for probabilistic input and computing the resulting output. So we have certain reference, we call it base case reference or base case scenario. What will be the worst case? We are looking to what will be the worst case situations or scenario. What will be the best case scenario in risk analysis? So there are several steps, 5 steps. Set up probability distribution for the variables. Build cumulative probability distribution for each variable. Establish interval of random numbers for each variable. And generate random numbers. After that, after having this information, then we simulate for a certain number of trials, certain number of experiments. Maybe 10, maybe hundreds, maybe thousands. Let's look into this example. Computer world laptop, computer sales. So laptop computer sales. Looking at this data, let's look into the demand. Maybe this company have recorded for the past 100, maybe 100 days, let's say 100 days, 20 of the days, no sales. Let's say days, 20 of the days, no sale. And then 40 of the days, 40 of these 100 days, sell only one in a week. Oh, sorry, this is in a week. So 100 weeks, say 100 weeks, 2 years. They collect data. Out of 20 weeks, out of those 100 weeks, 20 weeks, no sale, 0 sale. 40 weeks, 1 sale. 20 weeks, only 2 sales. 10 weeks, 3 sales. 10 weeks, 4 sales. Also bad. From this information, you can develop the probability. So what's the probability? So 20 out of 100, 0.2. 40 out of 100, 0.4. 0.2, 0.1, 0.1. So the probability of selling 4 computers, 4 laptop is 10%, 0.1. Probability of selling 3 is 0.1. Probability of selling 2 is 0.2. Probability of selling 1 in a week, 0.4. Probability of no sales at all, 0.2. Then we develop cumulative probability distribution. It means 0.2 or less, between 0.2, 0.6. Here, add up, 0.6 or less, 0.8 or less, at this one 0.2, 0.4, 0.2, 0.8, plus 0.1, 0.9, plus another 0.1, become 1. So the probability of selling 4 or less, it relates to this range of probability. It means anything less than 0.2, no sales. Anything 0.2, 0.6, 1 sales. If the probability 0.6 to 0.8, 2 sales. 0.8 to 0.9, 3 sales. 0.9 to 1, 4 sales. So we are going to use this number. So we generate random numbers. So we assign a certain set of interval for random numbers, say 0 to 0.19 or 0 to 19, that represent 0 sales. 0.2 to 0.59 represent 1 sale. 0.6 to 0.79 or 0.8 represent 2 sales. 0.8 to 0.9, 3 sales. 0.9 to 1, 4 sales. So what we will do, let's say each unit is sell at $4,300. Very expensive, this one. So how do? We generate random numbers. How are we going to do this? Spinning this thing. This is just an illustrations. We are not going to use this. So between 0 and 19, 0 sales. 20, let's say 0 to 19. Look back, 0 to 19. 0 to 19, 0 sales. 20 to 50, almost 60. 20 to 59, 1 sale. 1 sale. And 60 to 79, 2 sales. 3 sales, 4 sales. So if you spin this one, and then you put a point here and it strike to certain number, say 50, it generate. That means it reflect 1 sale. And then you play around maybe 10 times. Some may stop here or stop there. We can do that. Or alternatively, you will use a table of random numbers. In the past, we use tables of random numbers. These are tables of random numbers. So let's do the simulations. Let's perform this simulation for our case. Use 15 number. We represent random number, 15 random number in the first column of table 14.3, the table just now. The first 15 numbers in the first column. So this is what it means. You take the first 15 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 numbers in the first column of these random numbers. Not necessary in column. You can do diagonal. You can take diagonal if you wish. Diagonal or horizontal, it doesn't matter. But for illustration purpose, now we take this vertical. And let's do the simulations. How do we do? So this is the simulations. So these are the numbers we take just now. 39, 73, 72, 75, 37. Let's look at it. 39, 72, 73, 75. These are the numbers that we use. Now we put in this column. These are the numbers. And then this number represents certain demand. Like 39, what does it represent? 39 is in this range. It represents 1 sale. 39, it represents one sale. When random number generated is 73, 73 is somewhere here in this range. It represents two sales. 73 represent two sales. Let's look another one. Let's say our random number generated is 10. 10, what does it mean? This is the one we did. 10 is in this range. So it represents 0 sales. So this is the probabilistic input using random numbers. So this is the probable demand in the week 1 until week 15, maybe anticipate future weeks. Each unit sell 4,300. So 1 unit, 4,300, 2 units times 2, 4 units, 4,003 times 4. And out of the 31 weeks, out of this 15 weeks, we get 31 sales. So total revenue, we get 133,000. So we can have an average demand in the next 15 weeks. So about 2 laptops per week we can sell. This is how to predict how system operate, predicting our sales. So we can anticipate average revenue about 8,000. Here, average demand 2.07. Of course, we cannot sell 2.707 laptops, but it's just an indicative, maybe 2 or slightly over 2. Okay. Okay, let's look into more complex scenario. Photocom risk analysis. This particular company is introducing new printer. I just do a summary here. We will discuss further. The company want to know the profitability of the new printer, new model. Then it intend to sell at $249 per printer, per unit. Then the variable cost, direct labor per unit, it can vary from $43 to $47 per unit. And then the part or component cost, it can vary between 80 to 100. So the labor cost, the variation is probabilistic. And then the part or component cost is equally likely. That means it can between 80 to 100. That means 1 out of 20 chances will be 80, 81, 82, 83, 99, and so on. Whereas the direct labor is probabilistic in nature. So we need to use random numbers. Fixed costs, administrative 400,000, advertising 600. So total fixed cost is 1 million. And then the first year demand, based on past experience, when we do some analysis on similar product, it is normally distributed with mean of 15,000 units and standard deviation of 4,500 units. And then from predictions, the range of demand, it can vary from 1,500 units up to 28,500 units. So we want to know the profitability. So how to develop the profitability? We develop a mathematical model. What is profitability? Sales price, unit selling price per unit, minus labor cost per unit, minus part cost per unit, times the number of sales, number of demand, minus fixed cost. Okay, this one is this profit, unit price, less or minus unit labor cost times demand. We do not know what is the demand. It can be 1,005, it can be 28,500, or anywhere in between. And then less total fixed cost. This is known. So price is known. We refer this as parameter. Whereas labor cost, it may change between 43 to 47. The same thing, part cost, it can change at any time, it can change between 80 to 100. Fixed cost is fixed. Demand, it can vary also. It vary based on probabilistic situations. Okay, let's look at it in greater detail. So risk analysis, the process of analyzing the outcome of a decision in the face of uncertainties. This company manufactures personal computers and related products. So it developed new printer with certain features of better design. These are the financial information just now we depict. I made that summary. Selling price 249, administrative cost 400,000, and advertising cost 600,000, total fixed cost 1 million. Then you want to know certain scenario. What if analysis? That means generating values for the probabilistic inputs. That means direct labor, part cost, and demand, and calculating the outcome, the profit, the value of the profit. So this is the profit model. I think the same one which I showed just now. The profit model with profit equals 249, the selling price, minus labor cost, minus part cost, times demand, and then minus fixed cost. So this will be the equations, the simulation model, profit 249 minus labor cost C1, part cost C2, X number of demand minus fixed cost. Okay. Let's look into the summary again. Now the labor cost may range from 43 to 47. What's the median? This is the best case. Oh. This is the best case, is the, I mean, the good, very cheap. This is expensive. The same thing, part cost. This is cheap, this is expensive. So can you tell me between 43 and 47, where is the median, the middle?
45.
45. Okay, how about the part cost?
90.
90. So let's look into this. Let's say we use 45, part cost 90, and then we also look into the demand. The demand, we know mean is 15,000. Mean is the average, right? Average. So let's use demand 15,000. So we use this information 45, 90, 15,000 to calculate and plug into this formula. 249 minus 45 minus 90 times 15,000 demand. 15,000 demand, this one. And then minus 1 million, so we get 710,000. So we refer this as base case scenario. That means somewhere in the middle. And then in risk analysis, we are also concerned about the probability of a loss and also how much will be the loss. So let's look into another unit. In this case, what happened if the labor cost, part cost, and demand do not turn out as expected? And just now, labor can range from 43 to 47. Parts can range from 80 to 100. Demand can range from 1,005 to 28,500. So if labor cost is 47, parts cost is 100, and demand is 1,500. Okay, what does it mean? If part cost is 47, that means very high, highest. And then the labor cost 47, highest. Part cost 100, highest. And then demand is very low. This cost expensive, fixed cost is fixed, and demand is low. So we have another situation where if using the formula again, 249 minus 47, the highest labor cost, minus 100, the highest part cost, and demand, the lowest demand, minus fixed costs, we get negative 847,000. So the company can make a loss of 847,000. So this is referred as the worst case situations. Okay, what if, again, if labor cost is 43 and parts cost is 80 and demand is 28,000. Okay, let's look at it. That means in this case, labor cost is cheapest, minimum. Part cost is 80. And then demand is very good, 28,500. So we are going to have a scenario 249 minus 43 minus 80 times demand 28,500 minus 1 million. So we have 2.5 million profit. So in this case, we refer this as best case situations. So the profitability can range from the worst case, we make a loss of 847,000, to the base case 710,000, or to 2.591 million. This is the best case. Okay, well, will it happen or not? We are not so sure. Let's find out. So we want to simulate this. Let's do some simulations. But labor cost, part cost, and demand are unpredictable. It could vary or fluctuate over the period and not controllable. You cannot control this cost. So we are going to perform simulations. So we want to find the probabilistic inputs for direct labor, parts, and also demand. These are the probabilistic input. So we are going to assign certain probability. In this particular case, the estimate of labor cost is according to the following probability. The cost can be 43, 44, 45, 46, 47 labor costs. The probability of $43 labor cost per unit is 0.1. Probability of 44, 0.2. Probability of 45, 45.4. Probability of labor cost 46.2. Probability of labor cost 47 is 0.1. So let's develop a cumulative probability. So add this one, 0.1, 0.1 plus 0.2, 0.3. Yeah.
So the probability, you just assign it random, right?
This is from a study, maybe for the past 100 days, maybe 100 event.
Okay, okay.
And then maybe only 10 times get 43. It's not assigned. This is from analysis. I repeat, brother. Maybe on the past 500 events, 10 times 43, 20 times 44, maybe 40 times 45, 20 times 46, 10 times 47. So this is how they derive the probability. or maybe 100, 200 times, not necessarily 100, maybe 10 times. But to be more accurate, it's best to have 100s or more. So we develop this cumulative probability. That means if we are going to use this probability, we have to assign random numbers to this probability. If the random numbers are generated less 0.1 or less, that means the labor cost will be 43. If the random number generated is 0.3, that means 0.3 fall between 0.1 to 0.3, so the labor cost will be 44. If the random number generated somehow 0.5, that means it falls somewhere between 3.7, that means still 44. Then anything 0.7 to 0.9, this one, and so on. So this is estimating the labor cost. As we said just now, is probabilistic. So, and then the parts cost is uniformly distributed. That means equally likely. And this is maybe from the analyst's perceptions, equally likely. It can range 80 to 100, 80 to 100. That means about a range of 20. The probability of 80 is 1/20. Probability of 90, 1/20. Probability of 85, 1/20. So equally likely. And then the first year demand follow normal distributions, normally distributed. We have mean of 15,000 and a standard deviation of 4,005. Okay. Now we are going to develop we are going to use Excel to do this, to develop the simulations. So how to develop random numbers or labor costs. So we want to generate random numbers R, and assign each cost to the respective cumulative probability. I mean the direct labor cost, we are going to use Excel to generate random numbers R, and then we are going to assign this probability. If anything somewhere less than this one, the labor cost will be this one. If less than 0.3 and greater than 0.1, we 44. If 0.7, 45, 0.9, 46, 1 or 0.99, still 47, something. So anyway, in this range. So in Excel, we are going to use command if random numbers. The command is RAND. This open and close bracket, less or equal to 0.1. That means anything less than this one. Then we assign 43. If random numbers generated is less than 0.3, we assign the cost to 44. If random numbers is generated is 0.7, when assign the cost to 45. Then if random numbers generated is less or equal to 0.9, we assign 46 as the labor cost. Then if the random numbers generated is less or equal to 1, and then above 0.9, then we assign the labor cost to 47. So we develop this in Excel. You do later, just step by step first. This is how to generate random numbers for labor costs, because it is a probabilistic input. So, but for the part costs, we are having this equation. This is the lowest number, A, plus generating random numbers R, then the difference highest minus lowest cost. So the what we are going to do in the Excel, part cost will be 80, that means the lowest cost, plus the variations. The variation can be between 100 to 8, between 80 to 100. So there's a difference of 20, and then multiply by these random numbers. So we have the equation 80 plus randomly generated numbers times 20. So we are going to put in Excel these equations 80 plus random numbers times 20. So we get part cost. The next thing, demand. Demand is normally distributed with the probability, mean, or standard deviations. So what we have here, our demand is, we are not going to explain this Excel formula. The demand is normally distributed with certain randomly distributed with a mean of 15,000 units and standard deviation of 4,500. So in Excel command, in Excel, norm INV, random numbers, because it can happen anywhere. This number 15,000, this is the mean. It can range, can spread between this one, the standard deviation is 4,005, one standard deviation, two standard deviation is 9,000, three standard deviations 13,500. I mean, it can go to as high as 13,500 or as low as 30,000 minus 30,500. So the command for demand in Excel, we use this one. And the profit, now very straightforward. Profit, we are going to use profit 249 minus in the cell, the cost, and then the cell for labor cost, cell for part cost. X is the demand, 1 million is the fixed cost. So we are going to have Excel, in Excel, profit 249, labor cost, part cost, and then demand minus 1 million. So multiply. So this is what we get. We will demonstrate later. We run for 100 run. I don't show all the 100. You can use more. For this purpose, I just put 100 in the textbook. You can see 300. So this is the number of trials. 1, 2, 3 until 100. We did 400. So this is the formula just now in the labor cost, which I show you, put inside here, all here, formula for labor cost. Here, we put the formula in the parts cost, and then we put the formula for the demand, and this is the profit. That means trials, maybe one, if each trial represent 1 week, week 1, week 2, week 3, week 4, week 5, week 6. So we try to experiment for 100 weeks, for example. This is what happened. The profitability can make 500,000, can make 900,000, can go as high as 1 million, can lose 86,000, and so on. So to summarize, the average profit here, out of 100 trials, we have 783,000 to 31. And then we encounter the worst profit, minimum profit. We lose 396,000. And then maximum profit, 2.1. Out of 100, say 100 experiment, we encounter 7 losses. That means there's a probability of loss of 7 out of 100, 0.07 or 7%. Okay, let's compare this with our analysis just now. Base case. Our base case 710. Base case is somewhere about the average. So the average profit should be, in our base case, is 710. So we get more than what we initially anticipate. Minimum profit. The worst case which we estimated was just now was 847,000. After you do this experiment, we don't hit as bad as the worst case. We will only lose 300,000. And then the best case, we are expecting the best case 2.59 million. But from our trial, from our experiment, we only get 2.19. So this give you some indication by this simulating or this experiment. Okay, let's see how the experiment work. Okay, I show you this one. This is what we do for Takam, and you have this in iTaklim. Selling price, this we refer as parameter. Administrative cost, advertising cost. This is the fixed cost, the parameter here. And this is the labor cost. Just now I did mention lower random number, higher random number generated by Excel. We as anything less than 0.1, 0 to 0.1, we assign $43. Then on this one, 44, anything 0.1 to 0.3, 44. Anything, if the labor cost, if the random number generated is somewhere between 0.3 and 0.7, then we assign this labor cost until all this one. And then the part cost, the smallest value is 80, largest value is 100. Then the demand follow normal distribution, 15,000 mean, and then standard deviation is 4,500. So how do we do? Just now, this is the number of try, 1, 2, 3 until 100. Until 100, I do 100. We can do until 300 if you like. And then the part cost here, part. See how I do. This is what the formula I showed you just now. If random numbers generated, if random number generated is by somewhere in this range. I put this range. I think this one confused you. I use this one. If random numbers generated is 0.1 to less than 0.1, you assign 43 or 44. In this case, maybe it generates somewhere this number, it give 44. Parts cost, this is 80 plus a random number times 20. First year demand, normal, random, 1,005. Profitability, straightforward. This cell, okay, see the cell, labor cost, minus part cost, minus demand times 20, D20, what's D20? D20, the demand, first year demand, then minus 1 million. So you get the profitability, and then you can look at the experiment, encounter loss, encounter this loss, and then here good profit. Then you can run. That means this is just simulating a situation for say 100 weeks or 100 days, 100 weeks, let's say. And then these are the scenario you can generate. And this is the average profit, minimum profit, maximum profit. number of loss, probability of loss. So we refer as a base case just now, 710. You want to see this one, minimum profit. Our worst case analysis was 847. In this case, from our experiment, it may not hit this 800 and our loss 847. Even maximum profit, we cannot hit our best case scenario. Okay. So this is on Potacom printer. Let's have another one. This is risk analysis. Okay, let's look at another scenario about inventory. Inventory. I think you didn't learn inventory, so I had to highlight certain concept of inventory first. Let's say, who is an entrepreneur here amongst you all? Maybe brother, who was the imam just now? Brother Amirul is an entrepreneur selling this abaya. Do you know abaya, brother? Not this lady, this dress, abaya. So if you are selling, say, a new abaya and maybe a new design, then you want to stock in your outlet. How many to stock in your outlet? So the question is, when you do inventory, inventory means how many to stock. In this case, you have a question, how many to stock every month? That means every month, how many units to replenish? I mean, you have to order from your supplier, how many units? Then with this one, what will happen to your profit? And then how do you service your customers? Let's say when sister come to your shop, brother, and then you say, it is available. I think sister is happy, right? But if they come, they like this design and then out of stock, sister is very disappointed. He cannot get what she wants. And then brother also very disappointed because he failed to service to service sister. So now we want to know certain acceptable service level. Okay, let's say in our situation here, we sell this abaya at $125. And then the cost is 75. What's the profit? Can anybody shout the profit?
50.
50. The profit is 50. Let's say you make a decision to stock. So demand is normally distributed. Let's say from analysis of your similar design, normally distributed with mean of 100, standard deviation of 20. So we follow this normally distributed. So this is the level of inventory. That side is higher. This is the mean 100. Anything less than this one, it may be less than 100. Anything more than this is more than 100. Standard deviation of 20. Let's say you stock 100 units every month. So the first month, you stock 100 units. Let's say stock Q. And then on the first month, total sisters come who want to come and intending to purchase. There are 100 people. 100 sister, one unit each. So demand is 100. How many units do you sell, brother? Just one of the businessman, brother Amirul, or any other brother can answer.
Sell all of them.
Yeah, all of them, right? Because you have stock You stock 100. So during the month, there are 100 people, 100 sisters want to buy this abaya. So you sell how many? How many, brother? All of them, right? 100.
Yes.
100.
Mm.
So 100, you make profit how much? Total profit?
100 times 50.
100 times 50. Good. So you are selling, your sale is 100 units. What happened if somehow or other, another month, during the month, only 85 sisters want to purchase your abaya, and then you stock 100 units. What happened? How many units can you sell?
85.
85. Then any balance or not?
Yes, balance 15.
Balance 15. What are you going to do with that 15? You give free to people or you keep somewhere?
Keep.
Somewhat.
You keep to be resold for next month, right? So you keep. So here your sale is 85 because only you stock 100, and then the demand is 85. Then you can sell all the 85. But the balance you have to keep somewhere, and it incur costs. If you keep somewhere, maybe the cost per unit for 1 year is $15. So we refer this as holding cost. That means you cannot sell. For during the month, you have to keep, and you keep in the store, and then there is some rental in the store, storage, and then it costs you plus insurance, plus maybe you get some jaga or security guard to look after. Total maybe $15 per unit per year. This is one scenario. What if another scenario? There are 110 sisters who want to buy this abaya. How many units can you sell?
100.
100. 100, right? Because your stock is 100. So how many sisters can get the abaya?
100 only.
100 only. How many sisters cannot get the abaya?
10.
10. You as the entrepreneur, are you happy? Are you happy?
No.
You're not happy. You pity. Two things. You pity the sister don't get. But again, you lose opportunity for making money from that sister. You lose opportunity of making profit from these 10 units. Reason? Out of stock. You get the idea? You lose opportunity of making profit. So you lose what you call it, opportunity loss. There's an opportunity loss. So we refer this as stock out cost or shortage cost. You don't have enough in your stock. So we have shortage cost or stock out cost. It can be 50, you lose the profit. Or in this case, instead of you assign 50, you assign say $30 as a goodwill. This cost is not incurred. It is just like economic cost. Economic cost is some, if you learn managerial economy, you understand the concept of economic cost. This is just a goodwill and opportunity loss of 30. So in these situations, during the month, you can sell all, I mean, there might be 100 customers come and 100 of them get. And then there are also situations less than 100 customers come, and of course, all of them get. But there are situations more than what you stock. More customers than what you stock. So 310. So here we have to work out what we call service level. Service level is reflected. Say you stock a quantity Q, then we want to know the probability of your capability to service. because you cannot stock so much. If you stock too many, too expensive, too little, you may not be able to service the customers. So maybe you work out certain service level. This is called service level. Service level. And then there's a probability of stock out here on the right hand side. The probability of stock out. In our case here, the probability of stock out is 10 out of 100. Sorry, 10 of 110. About 99%. 89, 91%. Not 90%. So here, net profit is gross profit minus, you want to know the profit, gross profit. If demand is less than stock, you will incur holding costs. But if demand is greater than your stock, you will incur shortage costs. So this is the formula for profit. Everybody follow? The profit here, gross profit, that means 50 times how many units you sell, minus total holding costs, because we do not know this one, how many units, in what occurrence, we do not know how this will happen. So all this probabilistic, demand is probabilistic, this one probabilistic. So we are going to calculate this net profit. All right. So net profit, unit sold times unit profit, minus total holding cost, minus total shortage cost. So this will be the equation we are going to put in our Excel. Let's do some simulation. Yeah.
Why the shortage cost is expensive than holding?
This is, by right, it should be 50. Loss opportunity. Holding cost is actually something can be calculated. Here I say goodwill cost. This one up to you. You can put 10 or 20. So it's also okay. For this illustration, we follow the text. I put 30. But if you do inventory cost, inventory subject, our shortage cost actually 50. Loss of making profit should be 50. You get the point, brother? Loss of, here we lose opportunity of making profit from 10 customers, and each of them, if you have the stock, you can make $50 from each of these other 10. Actually, this is the outcome because you don't have enough stock. Okay, this is a brief concept about a brief lecture on inventory before we go to the subject. Okay, can I go on?
Yes, sir.
Okay, so let's look into this Butler Electrical Supply. You produce home ventilation fan, selling price, you put the same number, 125, cost 75, gross profit, of course you can calculate 125 minus 75, 50. Demand normally distributed with a mean of 100 and standard deviation of 20. And then the management want to use simulation model to determine the average monthly net profit using a particular replenishment level, that means the stock. And then also the management want to know the percentage of total demand that will be satisfied. We call it service level. Because sometimes very difficult to determine the stock, but at least we are happy. Let's say we allow 95% service level, that means it can happen, it may not happen at all. It's just a probability that when a customer comes 90 out of 100 times, of 100, say 100 days, maybe if 95, 5 of the days, oh sorry, I don't have stock, something like that. It may happen, it may not happen. It's just a probability. So if demand is less than replenish level Q, then a holding cost of $15 is charged to the unsold unit. That means your storage cost. Then if demand is more or greater than replenishment level Q, a stock out or shortage cost, I call it SC of 30 is assigned for each customer turn away. That means demand not met. Then the controllable input, that means the replenishment level of the inventory at the beginning of the month, Q. Q can be 100, 110, or 120, or see how later on. So we are going to put the probabilistic input for the monthly demand is normally distributed. We use this formula. No, 100 as the mean, 120. Service level is the ratio of total units sold to total demand. And then if demand is less than Q just now, if demand is less than your stock, your gross profit still 50, holding cost will be 15, demand minus D. That means the Q minus demand. That means your stock minus, that means just now in our illustration 15 units. So this is not 15 units. This is 15 the cost. This is the cost, holding cost. If sales is less than 100, I mean, that means 100 minus the sales or otherwise 0. Then for the net profit, total gross profit minus holding cost. So net profit 50 times the demand minus 15 times just another difference unit. So here sell gross profit, sell holding cost, sell shortage cost. Okay, it will show you afterwards, then you understand better. If demand is greater than your stock, then this is where the shortage cost is being applied. So we have 30. If demand is more than 100, then the difference we are going to charge 30. This is the formula. Then the net profit is the gross profit minus shortage cost. So this is the net profit, 50 times just another difference, the shortage cost. So sale of profit minus sale holding cost, sale shortage cost. And then sales, then we follow this now demand. If demand is more than Q, you sell Q. You sell Q, exactly Q. I mean, there is an unfulfilled demand more than Q. If demand is less than your stock, then your sales is exactly your demand. And then there is some remaining that you have to keep. And this will go to holding cost. This one will go to shortage cost. So here the demand, if sell demand is greater than 100 or replenish level, then your sale will be 100. Otherwise, if less, then your sale base equal to demand. So this is what I did. We did. So demand, sales, gross profit, holding cost, shortage cost, net profit. So you can look at this. And then this is the summary statistics. So the service level here, 93%. Average profit, 4,100. Standard deviation, 829. Maximum profit, minimum profit, 130 in the month. And then maximum profit, 499. And service level is 93. So we are able to do 93% service level. That means there's a likelihood out of 100 months, 7 of the month you are out of stock. Okay, let's look at how it's done. Okay, this is what we did. Look at this scenario, gross profit, holding cost, shortage cost, replenishment level 100, demand mean 100, and standard deviation 20. So here demand, this is the formula inside the demand. Sales, if demand is greater than 100, of course you can sell 100 only. Demand say 170, you can sell 100. If not, then B16. I mean, if this not greater, like here not greater, the second one not greater, you get you sell 94. It means you are selling as B17. Back to this. So gross profit 50 times C16, $50. I put 50 here. I don't do reference, times 100. Holding cost here, since all sold, we don't incur holding costs. You don't incur holding costs because all the sale 100. But look at the second one. The second one, the demand is 94, we sell 94, and then the balance 6 we keep some in the storage, we incur holding cost, but there is no shortage cost. So net profit is very straightforward. Sales D16, gross profit minus holding cost minus shortage cost, then there's your gross profit. So this one is 0. So we make, okay, on the right hand side is my own check. So we do a few experiments, say, let's say month 1, month 2, month until 100 month. This is what we did. And this is the service level. This is average profit, standard deviations, minimum profit, maximum profit. This is service level. That means the total sales over demand. This is sale over demand. Okay. I need to take a few more your hours. Okay, let's do another representation here. It's the same. It's the same. But now I bring this one to the top. Now I do more generic here. I do all reference here. Instead of using this one, I do some reference. I just want to illustrate to you something. What if, now take note the profit 4,246. Our stock is 100. Service level is 91. If I were to increase my replenishment level, if I were to order from my supplier say I can order in multiple of 10. So I can order 105. I can order in multiple of 10 pieces. So I can increase my replenishment level 110. Let's say 110. Your profit will increase. Your service level will increase. Okay. So your profit will increase, your service level increase. Let's say you increase your replenishment level to 120. Maybe your profit increase, your service level also increase. Your profit made no difference. Your service level increase.
I think the profit decreases.
Decrease. Okay, let's see what happened. Let's say I increase some more. Let's say I try 130. My profit reduce, right?
Yes, reduce more.
If I were to do 140, it reduce more. Maybe reduce. What I'm saying is the optimal replenishment level, it doesn't mean that when you fulfill all the service level, that means you want to increase this one, it gives you a good profit. It doesn't mean that. That means you must accept reality of there must be a certain stock out, because when you have too much in your stock, maybe your holding cost increase. That means that most of the time you have unsold stock. You have many unsold stock, your holding cost will increase, and that will eat into this profitability. You get the point? So you can, here, that means there is certain, it doesn't mean increasing the replenishment level, increase profit, well, of course, increase service level, but your cost may increase. This is about inventory. Okay, so back to this one. So you can also see some other concept of simulation. Some use system wingtip, like aeroplane want to know the how the air flow here, like aeroplane in wind tunnel. Here, stress test on the wingtips for this new plane. These are examples of simulation. Maybe there is some mathematical equations here. We do not know how they formulate, not as simple as what we did. This is an example of simulations. That's all. Okay, brothers, sisters. Any questions?
No questions, Doctor.
Okay, let's end our day. Let's end our day with the recitation Suratul As. Bismillahirrahmanirrahim. Thank you very much, brothers and sisters. See you next class. Assalamualaikum warahmatullahi wabarakatuh.
Doctor, next
Waalaikumsalam.
Wednesday is a holiday, right? So we can have next
Huh?
class on Monday.
What holiday?
I think Wednesday is a holiday.
So
So our next class will be on Monday, or we are gonna have class on Wednesday.
I prefer to have class. I
Oh,
didn't.
okay,
What if we have class on Wednesday?
I'm okay, sir.
How about the others?
Okay.
I'm okay, Doctor. Just wanted to clear it.
Okay. I didn't know it's a public holiday. I didn't check the calendar. Maybe we have class. Maybe I put in the in the group. I say class is on, because it's difficult for me to do replacement class using this Zoom things. Okay, sister, thanks, sister, for reminding. Okay, let's end our day.
Okay.
Yeah. Okay. So, yeah, brother. Okay, Assalamualaikum.
Can I ask you about the project? I have some confusion.
What? You want to ask now, or because somebody is about to say bye-bye now? Okay.
Maybe can I ask now, or should I just message you personally, or can I ask in group?
Maybe if it beneficial to the others, then it's also good to ask in a group.
Okay, sir.
Yeah, quickly.
Okay. Okay.
What is the problem?
That's all. I will ask in the group
Okay, go ahead. You don't want to ask?
because
Are you ask?
I have any questions, so I think I will ask in group.
Oh,
Okay, sir.
no, I mean it's whether you want to ask now so that everybody benefit from your questions.
Okay, maybe I will ask a bit now.
Okay.
Where's
What?
the slide? Okay, for the project of the, I want to ask about the assignment first about the Islamic perspective. Okay, for the Islamic perspective, we have to choose one, or we can choose more team, right?
Yeah.
Okay, so let's say I choose 4 team. So I have to tell about each of team, right?
Okay, can, yeah. But must
Okay, and then,
be, you must, okay.
And then the next thing is we have to synthesize with the decision science concept that we have learned in our class.
Yeah.
So for example, I take transportation problem, right? Okay, so let's say I have 4 team. So I will have to relate each team to the transportation, right? So I will have 4 synthesize like that. Or
Uh,
I
if you
misunderstood.
find it difficult, then you try to have separate argument. You cannot unify or how to put hybrid all this concept into one. Then you can do separate things. Okay. For example, transportations. So in maybe you try to relate something I do not know about honesty in transportations, problem like cost of this thing, try to minimize cost. And then part of this Islamic thing is to save money, not to be excessive. You can use this. I think you can use the surah somewhere, not excessive somewhere in the Quran. A lot of I think wala tusrifun. I mean, yeah, you must not be excessive. You can use that. The idea of minimizing cost is to reduce excess. That means reduce wastage. Okay.
Okay, sir. So it also stated that I can choose more than one decision science concept.
Yeah.
So for example, if I choose 40 before, and then I choose two concept, so I will have to make eight paragraph or something like that or not? Because
I don't really know what you are asking. Maybe I'm happy to you have the stamina to do 8 or 16. Yeah, it's okay, brother.
for example, sir, I take grateful.
Yeah,
I take grateful and adil, right?
yeah.
Okay. So and then I choose about the transportation. So
Mm,
for the synthesize and the discussion, I will have to relate adil and transportation. So
yeah.
first thing, and
Uh,
then the next paragraph, grateful and transportation like that.
okay, I'm grateful because the efficiency and the saving there. That means you are able to fulfill the obligation or not wasteful. Okay, I think okay, brother.
Okay, sir.
Okay. Okay.
Okay. We can
Okay.
end now.
Okay, we end now. Okay. Assalamualaikum warahmatullahi wabarakatuh. One more time.
Wassalam. Thank you, sir.
Welcome. Welcome. Okay. See you Wednesday.
Yes, sir.
We assume Wednesday is on. Okay, I am ending the meeting now.